Well, let's get to it. This is, as we were saying, a presentation on the history of deep learning, and it's a little bit weird to use the word history in this context because most of the things that we will talk about will have happened in the last 7 years, so from 2016 to the day that we are recording this presentation in 2023, and some others will be a little bit further back in the past, but ancient history for us will be 1998. So maybe we should be speaking about the development of deep learning, but maybe it's a good idea to speak about it in terms of history because it shows already a certain evolution and how very new discipline has already had a significant impact on our world and our research communities. As usual, I have used quite a lot of references, and I will be citing quite a few of them later, a few more of them later, but many of the ideas come from this page that very with lots of humor was named Skynet Today from Andrei Kurenkov. This is a very interesting, very detailed history, much more than I will go into today, so I recommend that you have a look at it. Any cleverly put historical thing probably comes from Mr. Kurenkov, and any mistake very likely comes from me. But let's start. I started it saying that life was placid in this maybe not totally successful AI world, and then something happened. What did happen? Well, in 2009, the ImageNet competition happened. The ImageNet competition is a contest to solve one very classical artificial intelligence and computer vision problem, which is that of image classification. You are given a large data set of images, and each image has a class assigned to it. For example, dog or cat, and some classes can be assigned to more general categories depending on how specific you want your system to be. But the point is that you have many images and many classes. I have even had a look at some of the classes. So you have goldfish and different types of goldfish, great white shark, you have cock and hen, you have stingray, you have electric ray. So there are quite a lot of classes. There are many example images for each class, and some of the classes are very specific. So basically the problem is to take a huge set, more than a million images, and design a system, probably an AI system, that can classify those images, that can assign the correct class layer, dog, stingray, electric ray, to each image. And to do that, usually there is a part of the set that is used to fine-tune, to set up the system. We will call that training in a second, and then another part that's used to see how the system works, how well it does. Okay? And that's image classification, which, as I was saying, is a very well studied and very popular AI and computer vision problem. In 2009, this ImageNet contest was set up, and in 2012, a paper came that would change things quite dramatically for many people. This paper was by Alex Krzyzewski and others, and was called ImageNet Classification with, attention, Deep Convolutional Neural Networks. And that paper, that very same year in 2012, the network described there was called AlexNet, after the name of Alex Krzyzewski, the first author, who was a PhD student at the moment, jumped from previous results from other non-deep learning networks. This was the first eruption of the deep learning networks into the mainstream, and this AlexNet drastically reduced the errors that the computer systems made when classifying images. From 26% error the year before, it jumped to 16.4%. So it jumped almost 10%. It reduced the error almost 10% in one single year by using this new thing, these convolutional neural networks, this what will become deep learning networks. That trend continued, and in 2013, the error using other convolutional neural networks went down and down. 2014, using something called BGG, it was 7.3. In 2014, using something called GoogleNet, the error went to 6.7. And thanks to a paper in this year, this performance was compared to here it is. This performance of deep learning networks was compared in this paper by Olga Russakovsky and others in 2014 to human performance, and the result was pretty surprising. Basically, in 2014, when GoogleNet won the ImageNet competition, human performance was measured at 5% error. Remember, we are distinguishing things like manta ray from electric ray, so it's normal that even human experts make some mistakes. And in 2014, deep learning networks were pretty close to human performance in this task of classifying images in this huge number of classes, some of which were very, very similar. But then in 2015, with the ResNet network, deep learning networks went over human performance and achieved 3.6 error as compared to the 5% error that human observers had. That trend continued in 2016 with 3.1 error, and in 2017, basically most of the teams were under this aforementioned human performance measure, this human performance barrier. So basically the contest was declared solved, and then it moved on to some other problems. With this moment, deep learning became very clearly capable of doing image classification. Not only that, for the first time, artificial intelligence, because deep learning is just a part of artificial intelligence, could do image classification better than humans could. And that was very surprising, and that was a very that was a watershed moment for artificial intelligence and for deep learning networks. And we will see in a moment what had changed from classical artificial intelligence to warrant this change. But before of that, okay, so suddenly this new flavor of artificial intelligence, these deep learning networks can do image classification. Can they do anything else? Well, they can. They very much can. In 2016, a company that then became part of Google called DeepMind designed a deep learning based algorithm to play the game of Go. This algorithm was called AlphaGo. In a very marketing wise move, they also marketed it with a very public Go game, because between a human and a computer, and that gave artificial intelligence, DeepMind, and this particular software, the AlphaGo, very sharp rise in popularity and brought deep learning back into the public imagination and the public conscience. But we will speak about this in a second.